Let's try and make some sense out of this outcrop. Let's take a closer look at the rocks that make it up and at any tectonic structures that we might observe. Okay, so here's a typical looking outcrop. We've got a lot of vertical kind of flakiness running through it. That flakiness is more concentrated in some areas and less concentrated in other areas. And that reflects the fact that we've got really two different kinds of rock here, two different related kinds of rock, both siliciclastic sedimentary rock. But this is shale, or technically it's not shale anymore. We'll get to that in a second, just over here. And then this is a sandstone. Here's a look at some of that gray sandstone. You can see it's gray, and you can see it's made out of sand. So that's a greywacke, a clay-rich sandstone. And greywackies typically form in deep marine settings, where they're deposited by giant underwater avalanches called turbidity currents. And then this mud deposit here that used to be shale is now super flaky in a direction that cuts across bedding. Here the two are actually kind of parallel, but we'll see that the tectonic cleavage, which is really what's making it split like this here, overprints the bedding. So let me show you an example of that. So this shale is no longer shale, it's slate now, and it's breaking with the slaty cleavage, and you can actually really see that nicely right here. This whole piece right here used to be one piece, and you can see the trace of bedding, the light tan layers and then the dark gray layers that alternate going through this sample, something like that. But then the dominant feature of this rock right now is the fact that it splits into these thin pencil-like formations. So this is an example of pencil cleavage, and it overprints the original primary sedimentary structure of bedding. Here's a pretty sweet sample. This is a Balma sequence, pretty much. So Balma sequences are named for Arnold Balma, this geologist who first described the characteristic pattern of sedimentary structures in turbidite sequences. So here we've got a beautiful graded bed at the bottom that finds upward, and then up here at the top we've got some planar laminations. We don't have some of the key things that we look for in Balma sequences with like cross-bedding, for instance, but this is a pretty nice sample. So here I am at the bottom of one of these beds, the bottom of an outcrop. You know, there's the top, I'm at the bottom, but also this is the bottom of a bed. So this surface here is the bottom of one of these turbidity current beds, okay, one of these turbidites. And you can see right up above me there, there's a distinctive primary sedimentary structure. Let's take a closer look at it. That is a heck of a tool mark. Here's some other tool marks, some parallel scratches and grooves running through the rock, and here's the one where you can see sort of has an asymmetric little divot with some striations coming off of it as whatever the object was dragged downstream. Let's return now to this original outcrop, and there's actually a fault here that's given away by a fold. So see if you can spot it, and I'll show it to you. Right here is the fold axis. You can see the cleavage fanning out to the lower left, and that is a drag fold on a fault plane that otherwise is parallel to bedding. So in addition to the amazing sedimentary story here, we have a cool structural story too.